Hey there, year 11s. We're going to do example 26 here. What you do here essentially is you're trying to problem solve, and remember you can use a CAS. I'm just going to get my CAS out and just clear. Let's do a new page here. All right. A householder has 6 laying hens and wishes to construct a rectangular enclosure, I see, to provide a maximum area. So we were looking for area for the hens using a 12-meter length of fencing wire. Okay. So think of it as you have 12 meters of wire. So that's 12 meters there. And you're going to fold this. You're going to crimp it so that you can fold it into a nice rectangle. So then what it'll look like overall is you're going to get this nice, beautiful rectangle. That's an enclosure. Okay. Now this rectangle implies that you're going to have a length. You're going to have a width. What do they say? Construct a function that will give the area of the enclosure A in terms of its length, L. So this is L. By sketching a graph, find the maximum area. Okay, so we already know that area of a rectangle is equal to length times width. True? And we know that the perimeter is 12 meters because that's the length of the fencing wire that's been folded into this rectangle. So if I added all of the sides together, it should equate to 12 meters. So I know that the perimeter is 12, and I know to find that it is 2 groups of length, so length plus 2 groups of width should give you 12. Another way of thinking about it is just 2L plus 2W equals 12. Divide everything by 2, you get L plus W equals to 6. And then maybe they want you to find L, didn't they? No, they wanted you to find area in terms of its length. Okay. So that means, ooh, what happened there? That means you want to find this. Now I got area, but it's got length, but width, I don't want the W. That's what they mean when they say in terms of its length. We don't want that W. So what does W equal to? I can rearrange this here. W is equal to 6 minus L. Can you see that? Subtracting L on both sides. And that is going to be useful because I can now substitute here. And if I do that, your area is now equal to length multiplied to 6 minus L. So that's area in terms of length. And they want you to find the maximum area. Okay, cool. So once you've got that, that's probably the hardest part there. I would now then go to my calculator, go to menu, actions define. A of X, so that's the area, is equal to, now don't use L because when you graph this, they only know how to use X. Okay, so it always has to be in terms of X. So it'll be X times 6 minus X. But remember, you know what X represents? It is the length. So here we go. I'm going to control I, add a graph, a bracket X, and ooh, that's pretty nice. I can almost see the entire graph. So menu, for 1, if I just change the maximum height to say 20, oh, there we go. I can see it. So this is my area function graph. I'm probably just going to do zoom box just so. Menu for 2. And I'm just going to select a smaller region to work with. Okay, so that looks nice there. All right, let's go. So I'm going to screenshot this so that we can analyze it in OneNote together. All right, so I've got my area function. Now, normally if the extended response question or short answer questions, they'll ask you for a suitable domain. And a couple of things that you should already note. This is your area and this is your X, or essentially L, which is your length. We know that length cannot be 0. And if I were to be even more technical, technically length has to be greater than width. So there's a point somewhere where length can't be bigger than the width. That would be the actual proper way to sketch it, but the question's not asking you to sketch and they're not asking for extra information. I'm just trying to say that if you did do those kind of questions, you need to not include this. You do need to figure out what's the restriction for length. because length has to be bigger than width. If length was equal to, say, 3, that would mean that the width has to be 3. That's why length plus width will equal to 6. That's a problem. We can't have them equaling each other. Length has to be bigger. So at the very least, length has to be greater than 3. Okay? So it can't be less than 3. So wherever on this x-axis, we cannot have length being smaller than 3, essentially. So when you sketch it, you got to be mindful, essentially. So that's the only thing. That's the only thing. There's a condition to what length can be. So that means the width has an effect as well. So if length has to be greater than 3, well then the width can only be less than a certain value. That's the point. Okay. But let's find out, if we were to sketch this, just to work on our skills here, what are the x-intercepts? We know that axis-intercepts 6, 1. So we've got from here to here is 0 to 0, menu 6, 1 again, and I'm just going to go over here. So you can see that I've got 0 to 6, but we knew that when the length cannot be less than 3, oh, sorry, I shouldn't confuse you anymore. That's just to find the x-intercept, y-intercept. So 0, 6. Our job is just to find the maximum. Let's just do that. Menu, 6, maximum, and there you go, 3, 9. So now I know that the top here is when x is 3, maximum area is 9. So this is where 3 is. Okay, so length clearly always has to be bigger than 3, and the volume, the area is clearly 9 when that does happen. Okay, and the other stuff that I was talking about, you can ignore. We answered the question. Okay, so find the maximum area that can be fenced. Well, the maximum area that can be fenced, therefore max area can only be 9. Is it in meters? Squared meters. Okay, so that's the maximum area that it can be fenced. This one can expect 9 squared meters. This is assuming that length and width can be different. So this length will then technically be 3 meters, and this is 3 meters. That's the only way for you to have the area of the maximum area that you can have. Okay, but that's essentially saying you have a square. All right.